Hello and welcome to the channel. This video is going to be short. It is about a math problem which appears quite simple, especially for someone who can read time from an analog clock. In fact, the authors could hardly imagine such an issue, as they found the task in a Russian book published back in 1975, while from the context, the actual problem seems even older. So when it appeared, digital clocks were very uncommon in Russia. In the description below, you will find a link to a Russian site containing another solution looking much shorter than my own presented here. However, I found their solution hardly to understand, even for someone who, like me, does understand the language. To be honest, I would be unable to understand the solution if I didn't solve beforehand. So, the problem. Is there a position of a correctly running clock when its three hands, hours, minutes, and seconds ones form a 120 degrees angle between each other? In other words, these three hands must trisect the clock face, split it into three matching parts. Here I suggest to pause the video and figure out the ways to solve the problem. At start, let's agree that all the distances will be angular and measured in degrees, which is quite natural for such a task. It will be also natural to disregard trigonometry and assume 0 mark to be the position corresponding to 12 o'clock, because this is where all the hands are located at midnight, when a day starts. Also, as opposed to trigonometry, we take clockwise direction as positive, which also has good reasons. The whole clock dial is of course 360 degrees, so the distance between two adjacent hour marks is 360 divided by 12, which is 30 degrees. Thus, 1 hour corresponds to 30 degrees, 2 hours to 60 degrees, and so on. Therefore, the arrangement of the hands at start of each hour, meaning h hours, 0 minutes, and 0 seconds, is 0 degrees for the minutes and seconds hands, 30 times h degrees for the hour hand. Here h is the number of whole hours, an integer from 0 up to 11. It makes no sense to consider greater values of h, since after the midday all hands replicate the movement of the first half of the day. Now let's find the velocities of the hands. The fastest is of course the second hand. It makes a full turn in 1 minute. So its speed is 360 degrees per minute. The minutes hand makes one turn in an hour, or 60 minutes. To find its velocity, we divide 360 by 60 and get 6 degrees per minute. Finally, the hour's hand in an hour covers the distance between two adjacent hour marks, or 30 degrees. Therefore, its velocity is 30 divided by 60, or half a degree per minute. Now let's disregard the second hand for a while and try to continue from here. Let's evaluate the number of minutes within the current hour, when the angle between hours and minutes hands is 120 or 240 degrees, denoted with letter m. Since we are looking for minutes within an hour, m must be non-negative and less than 60, and unlike h, m may be fractional. In order to evaluate m, we need to find the angles formed by minutes and hours hands after m minutes, relative to 0 mark. The minutes hand starts each hour at 0 mark, so to find its position we just multiply its speed, which is 6 degrees per minute, by the number of minutes m. The speed of an hour hand is half a degree per minute, and it starts an hour at 30 degrees. Therefore, its position after m minutes is half of m plus 30h. Since the movement is considered within an hour, neither of the hands could make a full turn. Therefore, the angle between the hands is just the difference of their positions. However, what we actually need is the absolute value of this difference, as we don't know which of the hands is ahead. Then we simplify the expression, and given that the angle must be either 120 or 240 degrees, the expression under the absolute value sign may take one of the four possible values: plus or minus 120, plus or minus 240. To avoid dealing with four different equations, we can write a single equation in the following way: 11 halves m minus 30h equals 120k, where k equals plus or minus 1, plus or minus 2. Solving the equation for m gives m equals 60 times h plus 4k, or divided by 11. Though four values of k provide four distinct values of the expression, given that m is non-negative and less than 60, it may take no more than two values within an hour. This can be seen by considering different values of h. However, I won't do that, since it takes much time and doesn't help solving the problem. Instead, I'm going to give few examples. However, before that, let's find the position of the hands after m minutes. To do that, we substitute the expression for m into the above formulae for hand positions. For the minutes hands, we just multiply the expression by 6, that's easy. The position of hours hand isn't actually necessary for the solution, but I will find it to use in the examples. So we substitute m into the formula for hours hand position. Then we simplify the obtained expression by taking outside the common factor of 30. Then after reducing to common denominator, we get another factor of 4, which multiplied by 30 gives 120. Let's test the result by taking the difference between the positions of minutes and hours hands, and we really get 120k, which is great. Now let's free the space by erasing the obsolete lines and moving up the lines we need. Now to the examples, which aren't really essential for the solution, but I believe will help to understand it. Assuming h equals 2, we get two appropriate values of m corresponding to positive values of k, 1 and 2. And since k is positive, the minutes hand is ahead in both cases. When h equals 6, the appropriate values of k are -1 and +1. So the minutes hand is behind in the first case and ahead in the second case. Let's increase the value of h to 10. Now, as you probably guessed, to provide a suitable value for m, k must be negative, -2 and -1. And in both instances, the minutes hand is behind. The arrangement with h equals 10 and k equals -2 is shown at the start of the video. Now to a bit trickier case, h equals 3. The negative values of k aren't worth trying, as the corresponding value of m will be negative. By setting k to 1, we get 38 and 2/11 minutes, and the corresponding arrangement of the hands. However, for k equals 2, the value of m is 60, which is unfortunately above the limit. So we have to agree with one position for h equals 3, and in a similar way for h equals 7. Now let's return the second hand out of nowhere and continue solving the problem. Or you may prefer to continue solving on your own. Let's calculate the angular distance traveled by the second's hand in m minutes. The velocity of second's hand is 360 degrees per minute, and this value has to be multiplied by the expression for m. Here is what we get, and I'm not going to simplify it. The number of full turns made by the second's hand is the integral part of m. Since a full turn doesn't affect the final position of a hand, in order to find the final position of the second's hand after m minutes, we need to subtract 360 times the integral part of m. And since the seconds hand starts an hour from 0 mark, nothing has to be added. The next step is getting the angle between the seconds and minutes hands after m minutes. So we subtract the position of minutes hand from the position of seconds hand and take the absolute value of z. We see that the fractions under the absolute value sign differ only by the factor 60. So we can merge them and simplify the expression. And again the angle between the hands is either 120 degrees or 240 degrees. This time we write the expression under the absolute value as 120p, where p is plus or minus 1 plus or minus 2. Let's erase few lines again and move the second term of the equation to the right hand side. Since the right hand side is an integer, so must be the left hand side. Let's find out how it can be. Number 360 is not divisible by 11. Neither is 59. Since 11 is a prime number, the product 360 by 59 is not divisible by 11 as well. Therefore, the product of first two terms in the numerator is co-prime with the denominator. This means that the only way to get an integer in the left-hand side is assuming that the third factor h plus 4k, name it q, is divisible by 11. Note that the factor h plus 4k is derived from the expression for m, which can now be written in a shorter way. M equals 60q over 11. Let's substitute that expression into the inequality for m. Then, after dividing by 60, we find out that q over 11 is greater or equal to 0 and strictly less than 1. But hold on, since q is divisible by 11, q over 11 must be an integer. There is only one non-negative integer which is strictly less than 1. This is 0, of course. Therefore, q is 0, and so is m. Remember that in general m is a fractional number. So, 0 value for m means that 0 minutes, 0 seconds, and not even a nanosecond more, passed from the start of an hour. In this case, both minutes and seconds hands must be at 0 mark, whereas the coincidence of hands is not what we expect. Well, after all, I shouldn't place back the seconds hand. I'll better remove it to avoid confusion, because the answer is no, and the hands never trisect the dial. However, this doesn't upset me at all, because I hope you like the video despite that. And this is the... Actually, I was rude to the seconds hand. Instead of removing it, I should have placed it properly and explain what we've got. The reason is that q equal to h plus 4k can be 0 in only two cases. H equals 4, k equals -1, and h equals 8, k equals -2. As you can see, in both cases hours and minutes hands form a correct angle. In either of them, the seconds hand is at 0 mark and satisfies the equation with p equals 0, while p must be different from 0. This makes both positions unacceptable, and this is the end.